What if all that massive energy that goes into crypto mining could actually be used to solve some of science's biggest problems? Well, that's exactly the promise behind a pretty unique cryptocurrency called Qubitcoin. And today, we're going to dive into its brand new Planck update, a change that could seriously transform blockchain from just a ledger into a global supercomputer for scientific discovery. So, at the very core of Qubitcoin is this idea called useful proof of work. It's a really simple but honestly a powerful idea. Instead of miners just burning electricity to solve random puzzles, their computers are put to work tackling real valuable scientific problems. This isn't just about making crypto more green, it's about making it actually useful. Okay, so to really get where Qubitcoin is headed, we've got to take a quick look back at where it all began. About a year ago, it launched with this really ambitious proof of work algorithm they called Qash. The whole goal with Qash was, super ambitious. It was designed to take regular old mining hardware and turn it into this massive, global, distributed supercomputer, specifically for running quantum simulations. So you've got the network doing two things at the same time, securing the blockchain and pushing quantum science forward. And the way it worked was actually pretty straightforward. A miner's computer would run a simulation of a complex quantum circuit. Then it would pull out key statistical data from that simulation. And finally, that unique data was converted directly into the block hash, which secured the transaction. The science literally was the security. Pretty neat. But, Quash had a problem. And it wasn't a bug or anything like that. The real issue? The world of quantum computing moves at an absolutely breakneck speed. To stay relevant in the world of science, the network just couldn't afford to stand still. It was definitely time for an upgrade. See, Quash was built for what scientists call the NISQ era. That's NISQ for Noisy Intermediate Scale Quantum Computing. In simple terms, all that really means is that the quantum machines we have today are powerful, but they're also really prone to errors or noise. Quash was designed around those limitations, but the whole field is just blowing right past that stage. I mean, the developers themselves said it best. They said that as the quantum field moves on towards things like error correction and more stable, logical qubits, the network has to evolve right along with it. Basically, to stay genuinely useful, it couldn't be stuck solving yesterday's problems. It had to keep up. And that's where the Planck update comes in. It brings two huge innovations to the table. The first one is a completely new consensus protocol called Superdense Consensus. And yeah, that's a nod to Max Planck, the father of quantum theory. Nice touch. So Superdense Consensus totally rebuilds the blockchain's foundation. Before, the network could only do one kind of work, but now it can handle multiple, completely different proof-of-work tasks, all running at the same time on the same chain. Okay, here's a good way to think about it. The old Qubitcoin was like a factory with just one single assembly line. It could only make one thing, the Qash proof of work. This new system, though, it's like a modern factory with a whole bunch of different assembly lines running in parallel. Each line is a different scientific task, and miners get to choose which one they want to work on. And get this, each of these tasks isn't just some add-on. It's a core part of the blockchain itself, baked right into the protocol. Each one has its own unique algorithm, its own difficulty target, and even a built-in schedule for when it starts or when it gets retired. It gives the network a ton of flexibility for the future. So you might be wondering, okay, but won't adding all these tasks mess up the block time? And that's a great question. The solution is actually really clever. The system just adjusts the difficulty for each task individually. So let's say there are 5 active tasks. Each one gets calibrated to be solved in about 50 minutes. The result? A block still gets found by somebody on the network roughly every 10 minutes, keeping that global block time nice and stable. All right, so we've got this awesome new multitasking factory. Now we need something new to build on one of those assembly lines, right? And that brings us to the second major innovation in the Planck update, the network's new flagship task, which they've named David. And this really gets to the heart of it. A multitask blockchain is a fantastic piece of engineering, for sure. But what new, useful stuff can it actually do? Well, the answer is something called quantum compilation. This is a super critical and really, really hard step in quantum computing. Basically, it's the job of translating a complex, high-level quantum algorithm into a standardized set of simple instructions that an actual quantum computer can understand and run. Yeah, the easiest way to picture it is like a universal translator, but for quantum computers. It takes all these different kinds of algorithms and turns them into one standard language that real-world quantum hardware can actually use. And this right here is the real game changer. The old system, Qash, it just spit out abstract data, hashes, numbers, that kind of thing. But this new David task is actually producing something tangible, something you can use, a validated compiler-grade quantum circuit. So miners aren't just making data anymore, they are creating the literal building blocks for new quantum software.
Okay, let's pull all this together. Why does this Planck update actually matter? What's the big picture here?
What it really does is bridge this huge gap between the theoretical world of quantum science and the practical world of actually running things. It's using this decentralized global network to turn abstract ideas into concrete, runnable circuits that scientists and developers can actually get their hands on and work with.
So if you remember one thing about Planck, just remember the number 2. It's all about 2 core innovations. First, you have the Superdense Consensus architecture. That's the multitask factory. And second, you have the David task, the quantum compilation engine that's producing these incredibly useful results. And what's really cool is that this new kind of work is a perfect fit for securing a blockchain. It checks all the boxes. The problem of quantum compilation is really hard to solve. But once a miner finds a solution, it's super easy for the rest of the network to check if it's correct. And finally, it's deterministic. The same input will always give you the same correct output. I mean, this table really lays out the whole evolution perfectly. The architecture went from single task to multitask. The kind of work shifted from quantum simulation to the much more immediate need of quantum compilation. And maybe most importantly, the output went from just abstract hashes to actual usable scientific tools. But maybe the biggest deal of all is that this update totally future-proofs the network. As quantum science races ahead, Qubitcoin can now just add new relevant tasks and retire the old ones that are no longer needed. It lets the blockchain evolve right alongside the very science it's designed to support.
And all of this leaves us with a pretty mind-blowing question to think about. We've just seen a blockchain completely re-engineer itself to help solve a critical problem in quantum computing. If the collective power of crypto mining can be harnessed for this, what other monumental scientific challenges could it tackle next?